Quick disclaimer, Learn from Mac is an independent educational project. We are not affiliated with, endorsed by, or sponsored by Apple, or any vendor or product covered in this course. Hey, welcome back to Learn from Mac. I'm Dennis, and today is day 07, the week 1 review. No new concepts today. We're building one complete HTTP load balancer from a blank box, start to finish, using everything from the last 6 days. Let's get into it. The goal is simple to state and satisfying to actually finish. Build a fully functional HTTP load balancer on the R4600 from the ground up, every layer from VLAN creation through virtual server activation, and prove with curl that traffic is actually load balanced across 2 real pool members. Here's what you need: an LTM licensed R4600, 2 backend HTTP servers, real or simulated with Python 3-m h.tp .server, a client machine that can reach the virtual server IP, and everything from days 01 through 06 already understood. VLANs, self IPs, nodes, pools, monitors, and load balancing methods. 3 quick concept reminders before we build, since this lesson is really about assembling them, not learning them fresh. Self IPs give the BIG-IP its own presence on every VLAN, carrying production traffic. No self IP, no health checks, no SNAT, no return routing. Pool monitors automatically stop sending traffic to a failed member. No operator action required the moment a check fails. And the virtual server is the only thing the client ever sees. From their side, the VS is the application. They never know pool member IPs exist. All right, 3 labs, and together they're the whole stack. First VLANs and self IPs, external and internal. Then nodes, a monitor, a pool, and the virtual server that ties it all together. Then real traffic verification, 10 requests split across 2 servers, and we simulate a member failure live and watch traffic reroute. Let's get into it. Lab 1, external VLAN first, untagged on the client-facing interface. Internal VLAN, same pattern, server-facing interface. Self IP on external, lock it down, no management services exposed here. Self IP on internal, default services allowed, so health probes can originate from here. Verify both and save. Lab 2, 2 nodes for the backend web servers, a tuned HTTP monitor cloned off the built-in default, a round-robin pool monitor attached both nodes as members. Confirm both members are available before moving on. And the virtual server that ties it all together with SNAT automap, so return traffic routes back through this box. Lab 3, from a real client, 1 request first, confirm a clean 200. Now 10 requests, watching which server answers each one. Now the real test, mark web server 01 down manually, write on the pool member, reason 6 requests, every single one should now land on web server 02 only. Re-enable it, confirm both members are back to available, and save. And that's a complete load balancer, built from nothing in one sitting. There are self-check questions on the lesson page worth sitting with. SNAT automap especially, since understanding why pool members need it is what separates it works from actually knowing why. Take a minute with those. Quick recap before we go. The build order matters, VLANs and self IPs first, then nodes and monitors, then the pool and the virtual server last, since it's what ties everything else together. SNAT automap rewrites the client source IP to the BIG-IP's own egress address, so return traffic always routes back through the box, not around it. A pool member marked down stops receiving new connections immediately and automatically, no manual intervention needed, and the real test isn't a green status field, it's 10 real curl requests actually splitting across both servers, which is what you just watched happen. All right, that's day 07 in the books, and in week 1 done, a complete working verified load balancer built from a blank box. That's a real foundation for everything HTTP and TCP profiles bring next week. If this was useful, hit subscribe. You won't miss a single lesson. Next up is day 08 HTTP and TCP profiles. See you there.